In this lesson, we're going to look at two examples where we're going to find the area between two curves. When we want to find the area between two curves, we're going to be on a closed interval a to b. So we're calculating the integral from a to b of whatever the top curve is minus the bottom curve. So the first thing that we're going to want to do is graph our two functions on the same xy plane to determine which is the top and which is the bottom. In this example, we're going to find the area between f of x equals the square root of x plus 1 and the x-axis on the interval from 1 to 4. Now with these two functions and this interval, we're really just in the first quadrant, so that's what I used for my graphing calculator window. I'm going to shade in the area that I'm actually looking for, the region. So I'm from 1 to 4 and everything between these two curves. The top curve you could see is that square root of x plus 1. The bottom curve is going to be my x-axis. So I have the integral from 1 to 4 of the square root of x plus 1 minus 0 dx. I simplified that expression, and then I took the antiderivative of the square root of x plus 1. We're going to evaluate it from 1 to 4. So I plugged in 4, then I plugged in 1, and then simplified. So we have that the area of the region bounded between these two functions, the square root of x plus 1 and 0, is 23/3 units squared. In the next example, we're going to find the area of the region that's bounded between x squared and x minus 3 on 1 to 2. Now, since I know that both of these functions are going to go through more than just the first quadrant, I just used a standard 5x5 window. Again, I'm going to mark off my region. So I'm going from 1 to 2, and I'm looking at the region that's between these two curves. X squared is my top curve, x minus 3 is my bottom curve. Don't forget to put your second function here definitely in parentheses, because we do have subtraction here and we're going to have to distribute that negative sign. So I have the integral of from 1 to 2 of x squared minus x plus 3 dx. Taking the antiderivative of that, I get x cubed over 3 minus x squared over 2 plus 3x, evaluating from 1 to 2, and I get 23/6 square units.